Is the MagicShine's R300 Bicycle radar a budget-friendly lifesaver or a safety risk? Since its release, YouTube reviews have been divided. Some rate it as great value for money, while others say false warnings make it unreliable and dangerous. Bicycle radars are designed to alert a cyclist to vehicles approaching from behind, and a driver to cyclists in front of them, via the integrated flashing light. We've spent a full year putting this radar to the test, including 1,000 kilometers of cycling in Florida, Mexico, and Eastern Europe. Today, we're cutting through the noise to tell you if this $129 radar is actually a smart buy in 2026, or if you should stick with the gold standard, the Garmin Varia. At first glance, the R300 looks very similar to the MagicShine Seemee DV camera. It uses the same small quarter-turn mount, the same robust aluminum and plastic casing with 2 control buttons on top, but instead of a camera lens, you get a massive focused LED. It's IPX6 rated for waterproofness and uses a standard USB-C charging port. The 2 new side COB LEDs significantly improve side profile visibility compared to the Seemee DV or the Varia. It weighs about 100 grams. Pairing it with a compatible Ant Plus cycle computer or your Bluetooth-enabled phone is easy. Once it's connected, you can control radar and light modes remotely, and, most importantly, be notified of incoming traffic. As the vehicle gets closer than 140 meters, the rider is alerted. At 70 meters, the taillight flash pattern shifts automatically, grabbing the driver's attention exactly when it's needed most. Another feature is PeletonSync. If you're riding with friends who have compatible MagicShine lights, all riders' flash patterns will synchronize. This makes it easier for drivers to estimate the distance and closing speed. However, the radar will not remain synchronized while it detects an approaching vehicle. While touring, the R300's battery consistently outlasted our bike computer. The advertised duration in high light and radar on mode is 8 hours, while we measured 5 hours in a controlled lab environment. Note that when the battery reaches 10% capacity, the unit goes into eco-flash mode for another 3 hours and eventually achieves the advertised 8-hour target. Most radar users will likely use the day flash mode, however, where the claimed 16 hours is in reality closer to 10 hours. Note that it is possible to monitor the R300 battery level remotely via computer or mobile app. Furthermore, a warning informs you when the radar battery level is low. The main purpose of the bicycle radar is to detect incoming traffic. This is done by transmitting a low-power radio wave behind the rider. The returning echo signal is proportional to the distance, size, material, and shape of approaching vehicles. In this screen recording, notice how the first vehicles are detected further away than the 140-meter range advertised by the manufacturer. In this second example, the first car leaves the driveway at about 180 meters away. At approximately 160 meters, the orange overlay and audio warning are triggered, but the target is still not visible on the display column nor on the overhead camera. At approximately 100 meters, the target appears at the bottom of the cycle computer screen. The alert returns to green when the car passes. The R300's oversensitivity is a double-edged sword and leads to the false positive controversy. But first, let's discuss what are false positives and false negatives. As a car approaches from the rear, its return signal strength increases, slowly at first, getting stronger as it nears the radar. In addition to the car's return signal, the receiver antenna also captures background noise or interference. This could be caused by nearby RF transmitters, moving obstacles like tree branches, or nearby perpendicular or oncoming traffic. As long as the main echo signal is significantly higher, the radar has no difficulty identifying the incoming vehicle. The challenge occurs when the noise and the car signal have a similar amplitude. Radar manufacturers design hardware and software filters to isolate the signal from the noise. If the filters fail, the incoming car becomes invisible to the radar, resulting in a false negative. Note the situation usually corrects itself as the car gets closer and the return signal increases above the background noise, creating a good signal-to-noise ratio. In our testing, we never experienced a car passing us without being detected. Some cars were detected later than others, however. On the other hand, an overly sensitive or inadequate software filter, designed to detect cars in a poor signal-to-noise ratio environment, may create a temporary imaginary artifact, identifying a faraway noise as a threat that does not actually exist, called a false positive. While less serious than a false negative, some YouTube reviewers found such warnings totally unacceptable and an absolute showstopper. We have experienced numerous false positives ourselves, but most were in urban or semi-urban environments surrounded by multiple hard reflective surfaces and perpendicular traffic. The computer would temporarily turn amber and beep, but no target dots were visible, the ghost target being further than 140 meters. The computer would eventually turn back to green. Very few, if any, false positives occurred on rural roads where we find most use for the radar. So for us, it was a minor annoyance. What can MagicShine do to improve the situation? They could implement a far-near sensitivity selector in the mobile app. Near would cut urban interference, while far would be practical in low-interference rural areas. This would affect the maximum detection range, a small price to pay for better signal accuracy, in our opinion. The big selling point for the R300 was always the price. At $129, and even lower with a discount code, it was the obvious choice for the budget-conscious. But the market has changed. The Garmin Varia RTL 515, the industry benchmark, is often on sale now for around $149. When the price gap is only $20, the MagicShine R300 becomes a much harder sell. In our opinion, it should now be sold in the $100 range. If you're on a limited budget or don't have or don't want a compatible cycle computer, the MagicShine 100 AD could be a valid option at $55. While the R300 detects vehicles up to 140 meters and initiates 300 lumen warning flashes at 70 meters, the 100 AD detects and flashes 100 lumens at 25 meters. We like the 100 AD's simplicity and PeletonSync feature, but found the battery life a bit short. They advertised 9 hours in day flash mode with radar, being closer to 6 hours in reality. I used the 100 AD during our last trip in the Baltic states, while Gilbert, usually riding behind me, used the R300. Notice the PeletonSync that synchronized both flashes. After more than a year, are we pleased with our R300? Yes, despite its flaws. We were particularly happy to have it with us after Gilbert lost his rearview mirror during our trip to Mexico. We plan to continue using it for the foreseeable future and are looking forward to an improved radar from MagicShine. Meanwhile, would we be happier with the Garmin Varia? Possibly. In any case, for us, a radar won't replace a good mirror and common sense. What should you buy? If you can get a Garmin at a similar price, we would suggest going for the Garmin. If you can get the R300 on deep discount and you're cycling mainly in low traffic areas, it would be a valid purchase. If you have a limited budget and like the idea of a radar-driven taillight, but do not care for an expensive cycle computer, the 100 AD is an interesting alternative. Do you have positive or negative experiences with a bicycle radar of any type? Share your comments below. Want to know more about bicycle radar? Click on this video. We're Pam and Gilbert of 2 Bikes for Adventure. Thanks for watching, and we'll see you on the road.